Hey everyone, welcome back to class. So in this lecture, I want you to be coding with me as we learn about the object orientation of R, how to use packages and functions, and how to do some simple data manipulation so we can then move forward and talk about in detail how to use R to do real statistical testing. Before I start, I'm going to just clean my environment. I'm going to use this little broom thing. And that cleans up my environment so I don't have any objects currently existing in there. I don't recommend doing that all the time, but I want a nice fresh start for you guys. And again, this is opening up RStudio and not R. So make sure they're in RStudio. Remember, my colors are going to look a bit different because I've edited them. All of yours are probably white and blue and gray. That would be my guess. And yeah, so we're opening an R Markdown file. You're going to be able to download an R Markdown file, a student version that you can then code along with me. And that's for your reference to practice. So again, this is kind of our overall goal. We'll probably not get to graphing and statistical tests, but really what I'd like you guys to know is that there's always more than one way to do things in R. And so if somebody tells you, well, there's only one good way to make a string of characters, then that's just not true. And so there's always going to be multiple ways to do things. And so you might have creative ways to create the things that I've made and do it differently. And that's totally okay as long as we're getting to the same spot eventually. We're also going to talk about specific types of values in terms of like R language. So that's going to be numeric versus character. And so that gets us a little bit different and a little bit broader than our language from the interval ratio and nominal and ordinal, but it's important to know this stuff in terms of R because this is the language that R is going to want to use. All right, so we're in an R Markdown file. We have the basic R Markdown file setup is going to be the YAML, which is the place where you tell it the authorship and the title. There's going to be just some written text. Adding anything like this in the text portion of the R Markdown file is just going to make it bolder and bigger. And then we're going to have R chunks. So this is code where there's three kind of like apostrophe looking things and then an R in curly brackets. This is where we're going to actually have our R code live. So our R code lives within the chunks. So if you write something in here, it's actually going to break it. So you have to make sure that our R code is surrounded by these two lines. So these are called chunks. You can always add new chunks with this little C+ option. So let me go and do that right here. If I wanted to add an R chunk, here's what it looks like, and I have to type code in between, otherwise it won't read it. But that's how R Markdown differentiates between code and text. So for the purposes of the class, when I'm doing walkthroughs, a lot of times they're going to be using an R Markdown because this will also allow me to do this within the slideshow framework. And so I told you I was making all the slideshows in R. The actual text of the slide comes in here, and when I do code, it's in here. That's kind of the general setup for the R Markdown. So a lot of times I'll see students that accidentally start writing in this area. Again, it breaks it. So make sure you're within these sort of brackets. Now, R has a lot of base functions. So these are functions that exist straight up on its own before you add any additional sorts of packages. That will get you a pretty far way in terms of doing statistical testing. But one of the beautiful parts about R is that it's open source, and there are academics and researchers all over the globe who have added all these additional packages for visualization and statistical tests that are more robust than base R. And so you may want to add those. So I'm first going to have you guys start by installing two separate packages. Now, I'm not going to do these. But there are a few different ways you can run these lines of code. So take a second, pause, and write install packages and in parentheses ggplot2. Once you have that written, you can run the code a couple different ways. You can click this top right-hand corner and click run while it's highlighted. So you can double click, highlight, and run. So I can run that selected line. Oh, this needs to be in quotes. Sorry, guys. I can run this line. And I already have it installed. So it'll just say, do I want to update it? I'm just going to cancel out. For you, it'll just properly run it. And you can tell that I actually did run something because my console starts to move and starts to change. So the console is where the code is actually being executed. You're just in a more helpful user interface in the our markdown format. And so it's a little bit easier to read up here. So you're going to install ggplot and you're going to install tidyverse for me. So once you have those two done, I'm going to pause, let you give you a second to type those out and pause the screen. Once those are done, I want you to comment those out. By commenting those out, by adding the number sign, it tells R the next time that you want to maybe run this whole chunk. So you can run the whole chunk this way. So you can select it, or you can just click here and run the chunk. It will ignore these two. You don't have to install every time. You probably really don't want to. And so you're gonna just comment these out. Okay. You've installed ggplot and tidyverse, right? Which gets us some additional packages, which have all of these functions aside from base R. And then we're going to load the library. So if you just install the packages and then try to use a function in ggplot that we haven't, and we haven't loaded the library, it's going to throw you an error, right? So in order to actually use the functions within the ggplot library, we have to load it. So you can double click it. The other way to run code is to click on Mac, it's command return. So whatever your version of command is on your user system, you can command return and run that line of code. I got a little green thing. I know it went because the little caret is closed. And so you can also run code that way. So base R is all of the stuff that's loaded in R without you doing anything else. That's going to get you pretty far, but you always are going to want to be looking for packages that may actually get you a little bit farther in terms of the sort of functionalities you have access to. Okay, so let's start to talk about the fact that R is an object-oriented language. This means that the bulk of the work that we're going to be doing with R is going to be creating objects to either put our statistical tests in or to then manipulate the data with. And so everything's going to be around this creation of objects and manipulation of objects. So we're going to start by creating our first object, which is going to be a vector of different numbers. All right, so we create vectors in this concatenate function. Okay, so this C in parentheses just means concatenate or put all of these things together. And then we're going to have all of these different numbers that we'll put inside of it, right? So we're going to put 3, 5, 6, 8, 9, 1, and 4. And then we're going to add this to an object with this arrow. This means create an object called point_low. Now, stylistically, each of these should be separated in the English language, like we do in the English language. So when you write something, you put a comma, you put a space in between, write the next thing. I'd like you guys to do that. You have to make sure that the parentheses are closed, otherwise it's not going to go. Remember, this arrow is creating an object. And so you have to put that, otherwise point low won't be created. And then point low, stylistically, I prefer you to have everything in lowercase and then separated by an underscore. This just makes it much more human readable. This is part of a thing called a style guide, which we won't get too much into depth in this class, but it just allows you to just create more human readable code, which ends up helping you in the long run, because if you make stuff that's not readable later on, then you can't reproduce your work. So pause for a second, write this down. Once you've done pausing, or you've paused and you've written it down, I'm going to select it, or I'm just going to put my cursor on. I can also just do that, command return, and I'm going to run that code. Remember, there's a lot of different ways to run the code. I could also just run the chunk. That works too, creates the same thing. I know that it's done because it's done over here. In the console, and we also see that I've created an object in the top right hand corner called point low. We see that it is a number, it's numeric. There are 7 different values. 1:7 just means 1 through 7. There's 7 values, and these are the different values that are in it. So this top right-hand corner in the environment actually shows us a lot of information about what we're working with. And we've created our first vector and our first object in R that we can then manipulate later on. Yay. So let's try a little bit more of a complex function to create the same sort of vector. So there's a function called sample in R, which takes a random sample of numbers between 10 and 20, and then and I can specify how many numbers between 10 and 20 I want. So sample is a function, right? It's going to perform a job for me. And that job is based on whatever the users had kind of programmed it to be, which in this case is creating a random sample. That first argument, so everything in between the commas in a formal function is an argument. The concatenate's a bit of a different example of that. So that's a bit of a special case, but in this case, there are 2 arguments that are happening within the sample function. The first one is the range of values we want to be within. In this case, it's 10 through 20, which is represented by a colon. And then the 7 is how many different values I want. So I'm going to create this object point underscore high specifically with the sample function. It's going to take 7 different values that are between 10 and 20, and I'll run it and I'll see that it worked because it came up over here, and we'll see that it gave me 7 different numbers that are between 10 and 20, and it took a random set of them. Now, because it's based on a random kernel, if I run it again, you can see that the numbers actually change in the top right-hand corner. So watch this one more time. Because it's based on randomness, it'll change based on every time I rerun it. So if you only want it once, just run it once. There's also a way you can set seed. It's the function to make it come the same random amount every time. But we won't worry about that right now. But if you run it again, changes the number, run it again, whoops. You see that the numbers change in our top right-hand corner. And we can see that it executed every time, right, in our console. The caret's going through, the code's going through. You'll also really easily be able to see in either your R Markdown file or your console if there is an error. It'll usually show up in red. So now I have 2 objects, right? And this is all kind of this theme of basketball. So that's why it's called the B-ball exercise. So we have a set of high points and a set of low points. We're then going to move into this world of data manipulation. So what if I wanted to combine those 2 vectors, or these 2 strings is another way to call them. If I wanted to combine them to create a new variable that just was points, that was a combination of both of these things, I can use that concatenate function again, or that C, and just put 2 arguments in it, point high and point low, and it's going to slam those together and create an object of 14 that has both of them in it. Very cool. So I can look at that points on its own. So if you have an object, you can highlight just that object. So double click just the object, command return, and it'll return that object right underneath it in our Markdown. I can do the same thing here, double click point high, command return, boom, it'll run it. And so if you wanted to just get a quick look at it right there, you can. So if you ever want to look at your objects, I recommend just double clicking that and then hitting command return, or you can just click points or type points and then run that line, and then it'll return it again. So if you just run the line of code with the object written on it, it'll do it. But you also don't need to rewrite it. You can just double click, select, and run it again. So now we've made 3 different objects, right? We can see them on the far right, point high, point low, and points. Those were all numeric. What if we wanted to do non-numeric or character type stuff? In this case, we can use that same concatenate function and then use parentheses or quotation marks, excuse me, and then put different character values in there. So this is making a nominal variable about how tall that player was, and I'm going to make a variable of 14 where I write out each one of these things. So pause, and I want you to write by hand an object called height, and you're going to have 7 shorts and 7 tall in that object. I'm going to pause and let you guys do that. You can pause the video as well, obviously. So I'm going to then select this line once I'm ready and I'm done. I'm going to run it, and I'm going to create that variable. So height is now, we have this object called height, which is a character of 1 to 14 that has 7 shorts and 7 longs. Okay, so we have our first nominal variable. And in R, we're just calling them character variables. But there's a way easier way to do that, right? That's pretty tedious. So instead of just using the C function and handwriting it, we're actually going to use this repetition function or rep function. And it's essentially going to take an argument. The first argument is what we want it to say. The second argument is how many times we want it to say it. And we're going to embed both of these things, the rep of the short and the rep of the tall, inside the concatenate function. So the replication of short and tall, both of those functions are living inside the concatenate function. So it's slamming both of those things together to create this new object called height. And then that height will have both of these things. So you can run these independently on their own. I'll show you what that looks like. I'm going to run it down in the console down here. So if I just did rep short 7, it would go short, 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 short. And then if I just did rep tall 7, I could do that on its own. It's going to go tall, 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 tall. But then if I wanted to add them together, I put them in that concatenate function and then run it and give it an object called height. And now I have this beautiful object 1 to 14 that does the exact same thing, way easier than the other by using this rep function. So that's where we start to get into the world of functions. That makes it just so much faster than just doing base R or doing things kind of by hand or the slow way in R. If you ever have any questions about what's happening in a package, you can do question mark and then the name of that package, and it should give you all of the information that you need in the far right hand corner. So it's actually double, it's not single question mark, it's double question mark. But then you can go back and on the right hand side, it'll give you a bunch of search results on how to use the rep function. So if you ever have any questions about a particular function, you can do that. Okay, so now say we have all of these vectors, right? And these strings within these vectors, but they're not quite data frames yet. We need to make a data frame. So now we want to tell R that height is actually just going to be a part of our data frame, and it's going to be one of our columns. So we're going to use this function as data frame to create a variable called height. And that height variable is going to just be what we've made before, right? So now we see that we did it properly because on the right-hand side, we have this variable called height. And in this data set, and it's got 14 observations with 1 variable in it. So we probably want to have more than 1 variable, but we made something else, right? We made this variable called points. So how do we then add that to create a data set with both of them? Well, we're going to use this function called cbind. Now at any point, obviously you should be pausing and writing this code as we go. But the cbind function is going to slam together these two vectors and these strings, and we're going to put them together and we're going to make a data set. And so cbind is going to take points and height, slam them together, and we're going to make this into a data set called bball. So now, not beyond just having this data set of height, we now have this on the right-hand side data set called bball, which has 2 different variables in it, which each have 14 different observations. What's also great is we can just look at that data too. It's fairly easy. So remember, when you create an object, you can just write the name of that object and run it. So type in bball and then run it. And you can see it'll give us a visualization of that. You can also look at parts of it. So maybe you don't feel like you want to look at the whole thing on its own. You can look at the front or the back. So head will give you the first few observations in B-ball. So it'll give you the first 6, or say I only wanted the first 3. I can add a separate argument that just says 3. So remember, in the head function, we're selecting our data set B-ball, and then we're telling it how many we want. And we can do the same thing for the tail. So these are just complementary functions that give you the front and the back end of your data set. Okay. So that is, I think, where we're going to stop for this particular moment. Now we've created a data set called B-ball that has 2 different variables in it, both height and points. And then we can kind of start to play around with what that data set looks like and maybe actually do some data manipulation at that point.